here we go. Find the domain. So we know that the denominator can't be 0, or x squared minus 1 can't be 0. This is x minus 1 times x plus 1 can't be 0, or x can't be 1, x can't be minus 1. So it's all real numbers except for those two. That means I have graph every place but those two places. And that means that, I'm going to move that there. That means the VAs are x equal 1, x equal minus 1. I've got two of them again. End behavior, that means I'm looking for HAs, OAs, or others. End behavior is 3x over x squared, which is 3 over x. This goes to 0 as x goes to infinity. So since it's going to 0, we have an HA, and the HA is y equals 0. Now I can put in what I know. I know I have a VA at 1 and negative 1. And I know I have an HA at y equals 0. Now we know the outside, what the outside's going to look like, and the inside is either an S or a U. So don't know yet what that is. But we're going to go after the x-intercepts. The x-intercept is where the numerator equals 0. That's where x is 0, so it's 0, 0. So there's a coordinate point right there sitting on the HA. And the y-intercept, well, it's going to be 0, 0. It's a twofer. It's 3 times 0 over 0 squared minus 1, which is 0 over minus 1, or 0. So it's also 0, 0. So I've got nothing. That means that my option then becomes pulling coordinate points. So I need to now, and that's why I put in the information I already have, because this tells me what information I need. I need to know, by the way, where the stupid graph is. Let's go back up on the one thing that we didn't make a note of, which we should have. What's the multiplicity of the VAs? Multiplicity 1, right? So that means that the arrows on either side of the VA goes in opposite directions. So once I know where the graph is, I know where the other one is. So if this is the VA, which is negative 1, I need a point to the other side of negative 1, negative 2. And if this is the VA, which is positive 1, I need a point to the other side, which is positive 2. That helps me pick what points I'm going to need. Now, if I want something in the middle, it's going to be miserable. I'm going to have to pick a negative 1/2 and a positive 1/2. That, it would not be fun. That screams to me the word calculator. I shouldn't tell you that, should I? So if x equals negative 2, I'll have 3 times negative 2 over negative 2 squared minus 1, which is minus 6 over 4 minus 1 is 3. That's going to be negative 2, negative 2, negative 2. So negative 2, negative 2. Now that tells me that my graph is down here. This also says to me this. If this arrow goes down, the arrow on the other side of the VA does what? Goes up because it's opposite multiplicity, right? I don't know whether this graph comes down, turns and goes back up, or this graph comes down and then forms an S. Don't know. Not enough information. Either side will tell me. If x is 2, I'll have 3 times 2 over 2 squared minus 1, which is 6 over 3, or positive 2. So 2, 2, 2. That means the graph is here. Now that means if on this side of that VA the graph is going up, what's it doing on the other side? Going down. That means I've got an S in the middle. A snake, yeah. Now I can of course test it out here. I'm going to put in negative a half, so I'm going to take 3 times negative 0.5 divided by parenthesis negative 0.5 squared plus minus 1.
On the top.
I did something wrong. What doesn't it like?
She has parentheses in front of the 3 and behind.
Get rid of one of the last parentheses.
I don't understand why it wants me to do that. That's not going to matter as much as making sure that denominator is in parentheses. Oh, yes. Okay, now I know why. Thank you. That's 2. So negative 1/2 is positive 2. So that says this guy is going up. Now remember, I've got recall, so I'm going to do second, enter, recall it back, change that to a positive 1/2. So delete the negatives. And I get negative 2. So it's down here, which I said was going down. So it's an S in the middle. Now what I personally would normally do is this. And I think we talked about this one time in class. As we have this little store button here, then I would say take 2, store that in X. Now you could do that separately, or you could do it in one line. So I could do this, and it says X equals 2.
I can't see if it's not this.
Oh, sorry about that. And just type in the formula. So 3x divided by parenthesis x squared minus 1 parenthesis, and then I can recall back to the x and say negative 2, store x, so now x is negative 2, bring back my formula, and it'll be negative 2.
Are we still shooting for another